Hello, quick video on the chain rule of differentiation. In our first year of A-level, we've looked at finding the gradients of basic polynomial. So for example, y equals x squared. What would be really useful would be to have a method to find the differential of composite functions like this one below, where rather than having x squared in the bracket, x in the bracket here as a square, we've got x squared plus 1 in a bracket all squared. And to do this, we use this chain rule here. I've written down here, so dy by dx equals dy by du times du by dx. So what we need is some variable u, which is going to effectively be our substitute. And in this case, our u would be what we've got in the bracket here, x squared plus 1. This formula down here relies on a pretty straightforward piece of maths that we might think of in the past, if you think about it generally, which is if I was traveling along at 50 miles per hour, and I wanted to know what that was, so that's a rate of change, isn't it? I would want to know what that is in kilometers. Then we know that kilometer is 8/5 of a mile if we did that ratio, and therefore I could take my 50 mph and multiply it by 8 over 5, and I would get 80 kilometers per hour. So all I've done is multiply two rates of change together to get my answer. So what I'm going to do now is take us through an example below this example we've got here and see how it works. Okay, so here's our function y equals x squared plus 1 all in brackets squared, and what I'm going to do is to turn that into two relationships. I'm going to have u squared where u equals x squared plus 1. So everything in the bracket I've called u, and now I've got two equations. That's all I've done here is have two equations. Okay, so let's have a look at differentiating these equations. You're probably okay with the idea that if I did this with x squared rather than y squared, then the differential would be u squared rather. Our differential would be 2x, and in this case, of course, our differential is going to be 2u, because if we do our little triangle, y plus delta y is going to equal u plus delta u all squared, and these two first terms will cancel out, and therefore our little delta y in our triangle is going to be 2u times delta u, and this term here is going to go to 0, and therefore dy by du equals 2u. And again, I'm sure we're all very comfortable with the idea that for the second one, if u equals x squared plus or 1, then following the same logic of a little change in delta x creates a change in delta u here, then, and cancelling out the terms are the same, we end up with our delta u is going to be our 2x plus delta x and the term going to 0, and therefore du by dx equals 2x. And if we combine the two here at the bottom, so if we take those two relationships we just created and do it in the little deltas form, we know that our little delta y it'll be 2u times our little delta u that's driving it. If our little delta u is being driven by our little change in delta x, then a little delta u will be 2x times delta x, and therefore if we substitute the second one into the first like that, then we find that delta y is going to be 2u times 2x times our little delta x, and of course we can rewrite that, can't we, into this relationship, dy by dx equals 2u times 2x. Now if we just bear in mind that we started from dy by du equals 2u and du by dx equals 2x, and we substitute those other relationships in here, we can quickly see we've got our relationship there, dy by dx equals dy by du times du by dx. So in summary, the chain rule allows us to differentiate a composite function. it's written in this form: dy by dx equals dy by du times du by dx, and we can use it to differentiate composite functions of form like this one here, so where y equals x squared plus 1 all in a bracket to the half, or y equals cos of 3x plus 1. And in principle, in each of these, what we're doing is a substitution for u, and we do so usually with what's inside the bracket to make our lives easier. So here u equals our x squared plus 1, and here u equals 3x plus 1. So I hope that's of use to you, and best of luck.